So again, you are on page 12. Today is the 24th. And we are going to be multiplying polynomial expressions. The 24th. By monomials. Okay, so let's break down that title again. Santano, what was an expression? No equal sign. So string of terms without an equal sign. What did polynomial mean? What did we talk about polynomial meaning on Tuesday? No? How about multiple terms separated by addition and subtraction signs? Remember we mentioned that on Tuesday? So I said like 3x plus 4x squared plus 5y. So it's a string of terms separated by addition and subtraction signs. What do you think a monomial is? One term. So it's going to be one term times a bunch of terms. Okay? Over the next couple days after today, we're going to be doing like a binomial times a binomial or a polynomial times a polynomial. It'll be fun. Cassidy's the only one that's like, sure, I believe you. Okay, so let's just start basic, and you're going to see why exponents was so important to us. Let's just multiply monomials. So a monomial times a monomial. Okay, that's where we're going to start. Multiplying monomials. Bless you. So that's a 3. So 6x to the third minus 4x, times negative 4x to the fourth. So 6x to the third times negative 4x to the fourth. So we're multiplying one term times one term. Okay. This should seemingly look familiar to you. The difference is when we were doing like exponent rules, we had the dot versus parentheses. But the same rules apply. Okay, so what did we start with? What should we start by multiplying?
Constant.
It's not a constant if it has a variable next to it, but it starts with a C. C-O... I heard it. Coefficient. So we're going to multiply the coefficients. So 6 times negative 4 is negative 24. And then what did we do with those exponents? So when you have x to the third times x to the fourth, what happens? You add them. And it becomes x to the seventh. Okay, so exponents are going to be important here because now, so with addition and subtraction, remember our variable, or I shouldn't say our variable because that doesn't change, but our exponent didn't change. We kept the like term and all we dealt with was the coefficient. When you're multiplying, your exponent's going to change like it did with the exponent rules. Okay, so let's just do one more of those before we get into monomials and polynomials. So how about 5xy squared times 7xy. So again, this follows exponent rules. So see if you and your group can give me an answer for 5xy squared times 7xy.
Which thing?
35x squared.
Oh, okay, so you did multiply these, but you didn't multiply these. How many x's is that? That's x to the... What power is that? Okay, and that's a 1.
So if we multiply our coefficients, 5 times 7 is 35. And we add exponents. There is one x here, so x to the first. And there is one x here, x to the first. So 1 plus 1 gives me 2 x's, or x squared. And then I have 2 y's plus another y for a total of 3y. So you should have 35x squared y to the third. Okay, so again, multiplying a monomial times a monomial. A single term times a single term, because now we're going to go into monomials times polynomials. You ready? I'll take that as a yes. There we go.
So you're saying there's a chance?
Okay, so we're going to multiply a polynomial times a monomial. And the nice thing is you've dealt with the distributive property for quite a few years now, right? And so a lot of it is combining what we already know and have done. Okay, so my monomial is 3x. My polynomial is 3x squared plus 6x minus 5. Just like from 6th grade on, when you have parentheses and you have a term on the outside of the parentheses, you use the distributive property to multiply it in. Okay, so we're going to multiply that 3x by everything on the inside. Now, where I see most students mess up is they'll multiply 3x times that first term and just be like, I don't really care about the rest of the terms, and or forget them. Okay, every single term. So one term at a time. Multiply your coefficients. So 3 times 3 gives me 9. I have an x to the first, and I have an x squared giving me x to the third. Good. So the 1 plus 2 gives me 3. Second term, 3 times 6 is 18. I have an x and an x. Good. X squared. You're counting up your x's. And then 3 times negative 5 is negative 15. And then I have that x on the outside that I'm just going to attach. Okay. Now, one thing I do want you to check for, and in this case we don't have to fix anything, but what should we check for these? The correct order, so standard form. Is it in standard form? Yeah, x to the third, x squared, x to the first, and then if there was a constant, it'd be there. So sometimes you need to rearrange it. Sometimes you're good to go and you don't have to worry about it. But you always should check for it, okay? Okay, why don't you try this one? We're going to, again, keep it basic, and then we'll add some things. Okay, so I have a negative x on the outside, and then 2x to the fifth minus 3x squared plus 7.
Real quick, as a recommendation, I'm noticing whenever there's a solo x with no exponent next to it, I'm noticing that people are forgetting there's actually a 1 in the exponent. And because of that, you're forgetting to add it. So if you need to, while you're starting the problem, just put a 1 in, just to help yourself out everywhere you see one, so that you know that you're including it in that problem.
Yeah, absolutely. What else is technically missing from in front of the x that could be confusing for people? A negative 1, right? So if that helps you to add those ones, by all means add those ones. Okay, if you don't need it, then you don't need it. But if you're missing it, that tells you probably need to do it, right? Okay, so negative 1 times 2 gives me a negative 2, x to the 6th. I have 1 here and 5 here for a total of 6. Negative 1 times negative 3 is a positive 3, x to the third. I have 1 plus 2 is 3. And then negative 1 times 7 is negative 7, and I just have the x to the first. Okay? All right, so let's throw in a y. Let's do x's and y's. Okay? We can do it. We're going to do it together. Okay, so 2xy times 5x squared y plus 3xy squared plus 7xy. Now remember I said standard form kind of gets a little funky when we start throwing in multiple variables. We're just going to multiply it out, and the order that it's in is how we're going to keep it. Okay, we're going to make our lives a little easier. But if it's a single variable, it should be in standard form. Do you want to do this together, or do you want me to just let you try it? What did we say? Try it on our own? Okay. I didn't know. Okay, if I multiply through, I have 10x to the third y squared for my first term. So far, so good?
Yep.
Okay. Plus 6x squared y to the third. And then 14x squared y squared. How do we do? Good? So good. Okay. Well then, what if we... What if I give you something like the... Oh, wait, ignore that. Hold on. Stand by. So what whiteout is for? I didn't want that parenthesis yet. What if I give you this? We can do it together if you'd like.
I want to try it on my own.
You want to try it on your own? Okay, fine, you do that.
This is cost.
That 2x on the outside here in front of the parentheses only gets multiplied to what's inside the parentheses. Okay, so that's going to be important. So just distribute to what's inside first. So 2x to the third minus 6x squared plus 4x. But I still have this 2x here. I need to bring that down. And then I need to look at my problem and say, am I done? And hopefully you answered no. What do we need to apply at this point? Like terms. Combining like terms. And what constitutes a like term? Same variable, same exponent. So my like terms are 4x and 2x. So everything else I'm going to rewrite. 2x to the third minus 6x squared plus 6x. Okay, so it's multiplying, and then it's a combination of the combining like terms that we did on Tuesday. A lot of you got that on your own. But again, make sure that this 2x in the front does not get distributed back here because it's not a part of that. Okay? Do you think we can do another multiplication and combine like terms?
Yeah.
Yes? Now that we've seen it? I think we can too. Take it one step at a time. Okay, I'm giving you a double multiplication and then a combine like terms. But I have faith. It looks like we got this one. So again, let's start with the first set of parentheses and distribute. 4x to the third minus 8x. Okay, that first set of parentheses is good. Then I need to multiply this second set in. Negative 1x times 3x squared is a negative 3x to the third. And negative x times negative 7 is a positive 7x. And then, as always, the last thing you check for is if there's like terms and in standard form. So my like terms happen to be 4x to the third and a negative 3x to the third, which is just 1x to the third or x to the third. 4 minus 3 is 1. And negative 8x plus 7x. Negative 8 plus 7 is a negative 1x. x. I see some smiles. That makes me happy. We literally are going to multiply a few more things, and then you have a test. So if you can add and subtract and multiply, it should be a good first test for everyone. Okay? Last problem, because you might see something like this too. And before you get angry at me, at least you'll see it.
Is there more staples?
Yeah, I think so.
No,
Um,
it's just a bad staple.
yeah, I think so. I'll do. Wait, do you have any more staples? I'm running out.
If you find yourself getting each one of these wrong, then you might want to raise your hand and just say, hey, what am I doing wrong?
So you have 2 people in here that can help you, which is nice. Not every class has that. Here goes again.
Just broke the stapler.
Okay. Let me see. Let me see. Let me see. Okay, I kind of threw a mini curveball. Not a big one, just a mini one. See if you can figure out what that curveball is. And if you can't, that's okay. We're going to go over it. Okay, I would say we're about 50-50 on figuring out how to do this problem. Okay, so everyone, I think as we went around, did the first part right by distributing the 7x. So you got 14x squared minus 42x. I would say everyone was okay there. And then I threw in a mini curveball. The only thing I did was I took this 2 and attached it to the end of the parentheses instead of putting it in the front. But it's still multiplication, so you still distribute to every term. Okay? If there was a plus or a minus sign in between, that's when you bring it down. But you have to be able to recognize the difference between whether it's being multiplied by the parentheses or it's attached with the plus or minus at the end. Okay, so if I distribute that in, I get 8x squared minus 14x minus 8. And if it makes you feel better, move the 2 in front. I'm okay with that. If that helps you, move the 2 in front. You don't necessarily need to, but you can. Last step is to combine like terms. 14 and 8 gives you what? 22x squared. And how about negative 42 and negative 14? Negative 56x. And then my negative 8 attaches to the end. How do we feel?
Great.
Great. Okay.